All right, so this is 6-5 day 1. We're going to look at multiplying and dividing in this lesson. So it's really important that when we go to multiply, we look at our index here and we make sure that they are the same, because we cannot multiply radicals that have different indexes. So that's kind of some examples that you see up here. So if we look at it with variables, we would multiply, since our index is the same, we can multiply our coefficients, so a times c, and then we keep the index the same and we multiply underneath the radical symbol. So b times d would be bd. And if these were obviously numbers, we would go ahead and simplify that. So let's look at an example with some numbers here. Since they're the same index, they're both the cube root, we can go ahead and multiply. So we do multiply those coefficients first, and then we keep it as a cube root, and we multiply underneath the radical symbol. So 9 times 9 is 81. X and x to the 5th, we add exponents when we multiply them. And then y to the 4th and y to the 2nd is y to the 6th. Z to the 2nd, z to the 2nd is z to the 4th. And then we go ahead and we simplify. So we've hopefully practiced enough of this where you know you're splitting up the 81, and 27 is a factor of 81, and 27 is a perfect cube. And then I'm going to leave my variables and just kind of do that dividing, or that thinking about the groups, how many groups of 3 I have. So that 27 comes out with the 15 becomes a 3. I've got my cube root. What's left is going to stay under is the 3. How many groups of 3 and 6? Well, there's 2 groups of 3 and 6. And then how many groups? Oh, there's another 6. We know that's 2 groups. And then z, we can only get 1 group of 3 out of the 4. And then that would have a remainder if we took 3 out of 1. So now the last step is to just multiply the 3 and the 15 to get a negative 45. So I'm just going to go ahead and change that, since it's the only thing I need to change there. So negative 45, and then I can go ahead and move those things over, which I can't do with my mouse there. And then we're done. Make sure that's a negative 45 there. All right, so try that next one, number 2, on your own. Notice that they are not the same index, which means we can't multiply them right off the bat. So what I want you to do is simplify this one, and then we'll go ahead and multiply after we simplify. So try it. If you're a little unsure, just don't pause and keep watching, but I do want for you to try it at least. So here's our first step. The cube root of 8 is 2. There's 2 groups of 3 and 6, so this can be simplified, all of it. Over here, though, the 17, we can't do the square root. The y, we can't take out, but that x squared, since it's even, we can go ahead and do the square root of x squared and get x out front with our negative. So the last step is to just multiply those things out front that are not under a radical. So we wind up with negative 2, x squared and x to the 1st is x to the 3rd, and then we keep our radical 17y behind it. We're going to go ahead and move on. This product property is basically just kind of separating everything. It's just another way to simplify. So since we've spent extra time simplifying, if you want some practice there, you can go ahead and do that, but we're going to move on to the division since we spent an extra day with that simplifying. So when it comes to division, it gets a little sticky. We've got some more steps to do. But what I do want you to remember is that we can't have a radical in the denominator spot. That is the issue. So what we want to do is we end up doing what's called rationalizing, which you've probably done before with just square root. So this first row here, we did square root of 3, we multiplied it by square root of 3 on the top and the bottom, and that ends up canceling it out. But that works when it's just the square root. When it's a cube root or something bigger, then we can't just multiply it once. We have to multiply it more than once to end up getting, because it's cubed, we want it to be to the 3rd power in order to get it out of there. So let's review. We multiply by square root of b, which gives us a square root b over, and this ends up just being the square root of b squared, or b. So if we do it with numbers, square root of 3, we multiply by that radical. Since it's just the square root, that will give me 2 of them in order for it to just come out. Be square root of 9 which is 3. And we leave the top since we can't simplify multiplying those. So let's take a look when it's a little bit bigger. So what we end up doing is multiplying by the cube root, but not just the cube root of b, because that would only get me b times b, or b squared. And then it couldn't end up coming out. So I really need another, and the way that we, instead of writing another cube root of b and another cube root of b, 2 of them, we just make this squared. So whatever our index is, this exponent is going to be 1 less. And that's always the case. So whatever our root is, we just make this exponent 1 less. So we keep the exact same thing on the top and the bottom, and then we multiply across. So what that looks like here would be 3 for our index, and we have a 3. What's the exponent? Well, it's always 1 less. So it would be 2. And we do that on the top and the bottom. So this one, let's go ahead and simplify. So we have the 2 out front. We have the cube root, and you can go ahead and make that a 9. It can't come out because there's no cube root of 9 to simplify there. So on the bottom here, we have the cube root. We can multiply under here. So that's 3 to the first and 3 to the second, which is 3 to the third, which is what we wanted, because now it can come out. Now it can just become 3. And there's no longer a radical, and we're done. Because 3 cubed is 27, and the cube root of 27 is 3. And we're done, because we can't simplify anything vertically. So let's take a look at the 4th root. Same thing that we are going to do, that we did up here, we're going to do down here, but we're going to make it, again, 1 less than the index. So if our index is 4, then this power is 3. And we do that on the top and the bottom. So next we multiply across, so it's 2, and then it's the 4th root of 27. And then we end up on the bottom here, we should know that it's the index 4, 4th root of 3 to the 4th, which ends up coming out and just becoming that 3. Which, if you need to write that step of it being combined, so doing 4 to the 4th, and then we can see that the 4th root of 3 to the 4th is 3. And then you can go ahead and do that step if you need to. So try that last one on your own. Actually, no, don't try that one on your own because that's n. Let's do this one together, and then we're going to look at an example on the back of the next page. So it's nth root of 3. Well, we want 1 less than n. So that means we're going to take and we're going to subtract 1 from n. So that's kind of our step always when it comes to this rationalizing piece. So this one we can't really simplify since we're just using a variable to represent our steps. So on the bottom, remember that what happens is it ends up canceling out and we're just left with our base. So let's take a look at another example here on the back with some more numbers versus variables. So remember, we cannot have a radical in the denominator spot. So that's just kind of all those steps that we just did, kind of written out in variable form. If that's confusing to you, don't focus too much on it. But remember, when it's squared, we just multiply it times itself on the top and the bottom, whatever that denominator is, because that multiplied there is the square root of 4x squared, which ends up just getting us the 2x. Cancels out that radical. So when it's cubed, we do 1 less. Or when it's to the 4th, we do 1 less. So let's take a look here. It's going to be the cube root of b. 1 less than the index is 2. So now we wind up, since they're both the same index, we can multiply them, a and b squared. And on the bottom, it ends up canceling out and just giving us our b, our base. So for the 4th, this one gets a little sticky. If you can simplify vertically, if it's under a fraction, they're the same index on the top and bottom, treat it like a fraction and try and reduce it before you rationalize it. That can help things go easier. So 5 over 15 can reduce to 1/3. So I'm going to separate them too, because you can give the 4th root to the top and the bottom. So I'm going to both simplify vertically and separate them at the same time. So x to the first over x to the second, we subtract exponents when they're vertical. So 1 minus 2. So that means I just have 1 left on the bottom. Oh, and my 3 for the 1/3. And then 1 minus 2 is 1 on the bottom left. So it kind of cancels that 1 out on the top and 1 out on the bottom and just leaves us with 1 in the denominator spot. So what we're going to do is rationalize. So it's the fourth root. So on this one, I'm going to go ahead and make sure that everything is 1 less than this index for its power. So I'm going to do 1 less, so 3 to the third, x to the third, y to the third. And then we're going to do that same thing on the top. So now we can go ahead and multiply and simplify. On the bottom, we know that it's just going to get us 3 to the fourth, x to the fourth, y to the fourth, which means they can all come out. So it's going to be a 3xy on the bottom. Again, if you need to multiply and combine them and then do the fourth root of it, you can do that. On the top here, the 1 multiplied by everything just gives me everything. So it's the fourth root of 3 to the third, which is 27. X to the third, y to the third. And we can't simplify, since this is under the fourth root and this is not, we can't simplify vertically after that. So we are done, and there's no radical in the denominator spot. So go ahead and try this next one on your own. Remember to make sure that your exponents are 1 less. If it's already is 1 less, then think about how many you would need to get it to be that index. So for example, and I'll get you started, it's going to be the cube root of 3. Well, 1 less would be 2, since I've got 1 here, but I've got 2 x's already. I really just need 1 more to get it to be cubed, so I'm just going to put 1x underneath there. So next, you're going to multiply that on the top. So multiply across and simplify. And then check your answer when you're ready. So here's step 1. We just multiplied, leave the x out front, multiply the radicals that have the same index. So 3 times 4 is 12. Bring the x over, bring the y over. On the bottom, multiply those. I just went ahead and did that step, even though you know it's going to be a 3x left over. So it's 3 squared and 3 makes 3 cubed. X and x squared makes x cubed. Now we can go ahead and pull those out, which is just a 3x, since they're both cubed, and we do the cube root. And then we can go ahead and look up here for our numerator. There we go. And that's it. No radical on the bottom, so we're done. So if you need the next one, follow along. If not, pause it and try and do that one on your own, and then check when you're ready. So for this next one, number 4, we want to split it up if we can't simplify vertically. The only thing we can do vertically is this x to the first minus 3, which becomes x squared on the bottom. And then we can split up our 5th root, give it to the top, give it to the bottom, and we can go ahead and rationalize now. So we want 12 to the, well, we've got 1 here, so that means we need 4 over here, so that when we combine them, we'd have it to the 5th. This one, x to the 2nd, so that means we need 3 of them to get to 5 when we go ahead and multiply. So sometimes it is, or most of the time it is 1 less than this because we've only got 1 here, but sometimes we'll have more than 1, and we just need to make sure that when we add them, that it gets to be that same index so that it can come out. So we do that on the top and the bottom. So that way it kind of keeps things balanced. And then we're going to multiply across. So it's 5th root of 7 times 12, which is, what is 7 times 12? Too much mental math. Okay, 7 times 12. Thought I had that written down. 84. There we go. And it is x to the, oh, nope, sorry, it's 12 to the 4th. That's why I didn't do it on my notes, because that's going to be a huge number. So let's go ahead and keep that as 7 times 12 to the 4th, x to the 3rd. There we go. Okay, and on the bottom we have the 5th root of 12 to the 5th and x to the 5th. So the only thing that we've got here on the bottom, we know it's just going to be a 12x because we can pull those out since they're both to the 5th root. And on the bottom here, going to simplify that, if we multiply those and then try doing the 5th root, we can actually do a little simplifying there. So we'll do an example in class, but I'm just going to go ahead and simplify that already. It's 2 and then with 5 to the 4,536. And then we also have our x to the 3rd under. And we'll go ahead and finish the rest of these examples in class. Try a few, but we'll check in class.